All right, trig lesson number 5, angles of elevation and depression. Picture gives you a good illustration of what's going on. What I'd like to emphasize is that the angle of elevation always starts from the horizontal. Right? It's either the eye level of the bird or the plane or whatever is looking up here and rotating down for angle of depression, or it's eyesight, so you're looking straight ahead or horizontally and then rotating up for angle of elevation. But it always starts at the horizontal, right? That's something to keep in mind. So we're going to look at trying to solve real-world problems using angle of elevation and angle of depression. So let's take a look. We have an airplane landing. Pilot looked down at the air traffic control tower at an angle of depression of 35 degrees. So it's an angle of depression 35 degrees. The tower is 20 meters tall. And according to the gauges on the plane, it's at an altitude of 1,450 meters. All right, so first thing I'd suggest we do is draw a little diagram. So we have our plane here. We have tower here. So we know that tower is 20 meters high. We know the pilot is looking down at that tower, angle of depression. So the pilot's looking forward, so it's starting at the horizontal and rotating down at 35 degrees. We can draw the triangle over here if we so desire. It said he is at an altitude of 1,450, but with that 20-meter tower, and this is definitely not to scale, we could have a right angle here, and then this would be 1,430 because we have the 20 meters here. Again, even though it's not to scale. All right, so we would like to find how many meters it is directly to the tower. So not sure what's up with that. So there we go, there's x. Looking at this 35-degree angle, this angle also has to be 35 because they're alternate interior angles. Again, the horizontals are parallel. We have a transversal, so alternate interior angles are congruent, so that's a 35-degree angle also. We know the opposite side from that, and we'd like to know the hypotenuse. Opposite and hypotenuse sounds like a sine problem. So we have the sine of 35 degrees equals 1,430 over x. And to solve for x, we'd multiply both sides by that x. And then we would divide by the sine of 35 degrees on both sides. That would give us x approximately equal to 2,493.13 meters. And there we go. Not a lot different than what we have been doing, other than you have to construct the diagram on your own. Let's continue. We have an escalator. That escalator is from the ground floor to the second floor of a department store. It's 110 feet long. So here we go. Escalator is 110 feet long and it rises 32 feet vertically. Again, definitely not to scale, but we get the idea. What's the angle of elevation? So here we go. We're at the horizontal. That has to be our right angle. This is the value that we're looking for, the theta, or the angle of elevation. Again, from the horizontal up to the escalator stairs. So from theta, we know the opposite and the hypotenuse. That's going to be a sine problem. So we have sine of theta equals 32 over 110. In order to solve, we're going to have to take the inverse sign to undo what the sine does to theta. And we have to do that to both sides. So inverse sine of 32 over 110. Again, inverse sine and sine undo each other, so we have just theta on the left-hand side. And if we do the inverse sine of 32 over 10, we will have 16.91 degrees. Think we're looking okay there? Excuse me. Let's continue. We have two buildings 500 feet apart, so I'm going to put that 500 right in here. Angle of elevation for the top of the building is 23. That should be there, so 23 degrees there. Angle of depression would be 50 degrees. How tall is the building? So it looks like we're going to have to break this into pieces. I might call that top part from that horizontal to the top X, and from the horizontal here to the bottom, I'd call that Y. So we're going to have to solve for both of those and then add them together to get the height of the second building. So let's take a look. From the 23 degree angle, we want the opposite, and we know the adjacent. Opposite and adjacent, I believe, is tangent. So we have tangent 23 degrees equals x over 500. Multiplying both sides by 500 to get rid of that division by 500, we would have x equals 500 tangent of 23. That should give us 212.24 feet. So we now have the x value. We need to go for the y. We know the opposite. We want the adjacent. So again, tangent of 50 degrees equals y over 500. Multiply both sides by 500 again. 500 cancel. We have y equals, and from your calculator, 500 times the tangent of 50. I believe we'd end up at 595.88 feet. If we add those two together, right, add them up, we'll end up at 808.12 feet. So that would be the height of the office building. All right, so we're going to the back side, so flip the page over. All right, the shadow of a lighthouse is 19 feet long, and the angle of elevation from the end of the shadow is 75 degrees. How tall is the lighthouse? So there's our lighthouse. There's our 19 feet. And this would be about our 75 degree angle. We're looking for that side. From the 75 degrees, X is the opposite side. 19 is the adjacent side. Looks like tangent again. So tangent 75 equals X over 19. Again, multiply by 19 on both sides to get that 19 to the left and X by itself. So we'll have X equals 19 times tangent 75, about 70.91 feet. Continuing on to the second to last problem. We're moving forward. We're getting there, folks. The sonar operator on a ship detects a submarine at a distance of 500 feet from the ship, measured directly or directly measured. The angle of depression to the submarine is 40 degrees. How deep is the sub? So we have a boat sitting up here. We have a submarine sitting down there. Again, the ship is looking straight ahead. The angle of elevation, angle of depression, because it's coming down, is going to be that 40 degrees. We know that the distance from the ship to the sub is 500 feet. We want to know how deep the sub is. Again, we have our right angle there. From the 40 degrees, we have the opposite and the hypotenuse. So we would have sine of 40 degrees equals the opposite side x over the hypotenuse 500. Multiply both sides by 500. Get x by itself. X equals 500 sine 40, which should be about 321.39 meters. And lastly, you're standing 350 feet, measured along the ground, from a skyscraper that is 750 feet tall. What is the angle of elevation from you to the top of the building? So there's you more or less. We have that 750-foot skyscraper. We know your distance from that skyscraper at the base is 350 feet. Question is, oops, that was good. What's that angle of elevation? Theta. Again, opposite over adjacent. That would be tangent. So tangent of theta equals 750, or opposite side over the adjacent side, 350. Again, to get solved for the angle theta, we have to take the inverse tangent of both sides, so we undo what tangent is doing to theta. Again, we must do that to both sides to keep it balanced. Inverse tangent, tangent, undo what the other one does, so that leaves us just theta. And if we actually take the inverse tangent of 750 over 350, we should end up with about 64.98 degrees for our angle of elevation. There we go. Good luck. Have fun.